Hi, I'll try to keep this a bit more interactive. Just shout your answers if there are any, and I'll repeat them so everybody in the recording can also interact or hear what we're saying. But let's dive into 3 misconceptions about RAG. Before I dive into RAG, just to be sure, like, who knows what RAG is and how RAG works? Who would like a refresher? Okay, I see still a few hands going up on RAG. It's always good to dive into the fundamentals of what we're talking about. Like, Retrieval Augmented Generation has, 3 parts or 2 main parts. So how I would always describe this is we have your question that is coming in. That is the top left corner where you see custom question. And then you could use an LLM just to answer that. But the problem about that is that maybe the LLM is too old and doesn't know what you're asking about. So if you ask for very current information, the LLM probably doesn't know about it yet. Or you might ask about some data that is private or that is too specific that the LLM doesn't know it. And the idea about RAG is that you provide additional context to the LLM that it can give you better answers. So the classic example would be you're working in a big corporation and you want to know what your insurance plan is. And a generic LLM has obviously no idea what your company's insurance plan is. So you would need to provide the context what your company's insurance plan is. So what you do is when you basically, the customer question, we go down to the business data. This is where you could provide your specific context. That would be your insurance plan, for example. So based on the question that you ask, you retrieve the relevant data. Then you forward that data to where the plus sign is, where you have the question and the custom context that you provide. That is going to the LLM, and you instruct the LLM to answer the question with the context that you provide. So you would add your insurance plan that it can then give you the right answer. Potentially, you could even pull data live from the internet if you need to query something really up to date to this minute that is not in your business data, but that is an optional step. But the general idea is that you retrieve additional context that your LLM can give you better answers. That is the general idea about RAG, and then there are 100 little details about it, but this is the bigger picture. So why am I talking about that? I work for Elastic, the company behind Elasticsearch. We're the most widely used search engine that you can run yourself. I've been talking about search for almost a decade at this point, I want to say. So if you've never seen Elasticsearch, if you search in Wikipedia, behind the search box, our software is doing the search, and in many, many other places, if you try to find something, we're often involved. That's why we are very keen on that entire RAG topic and also some of the misconceptions. So let's see how this is going. For those of you who have used more RAG before, who agrees that you have to use vector search for RAG? 1, 2, 3. Okay, this is one of the points where we would disagree, because RAG, the retrieval part, is really just retrieval in any sense, whatever is relevant. It doesn't have to be vector search. It's just getting to the relevant answer. And it's actually funny that maybe Google is biased for me, but I just took this screenshot before when I typed in vector search is, and the first result is not enough. That is the one where we would agree. Anybody wants to shout why vector search might not be enough? Or where is vector search great and where it is not great? So maybe let's start with traditional, or sorry, yeah, please shout.
It's not great for really complicated filtering. Like, you need to filter a lot of things out of your.
Yeah, so it's not great for filtering. That is one aspect. I think that is actually a good point and very specialized. So maybe let me take a step back around the classic way to search something was keyword search. So it's very much like you match a string or a substring and you try to find that concept. And that works very well as long as you use the right words. And that is very much what we have been trained for many years, that we have a search box and we think like, what are the keywords that I need to type in that are existing somewhere that I want to hit, and then I want to get something back. And that works. And maybe you define synonyms that even if you use a different word for something, it will still find something that is relevant for you. So that works, but where it doesn't work so well is if you have this more vocabulary mismatch, you didn't define the right synonyms, you described more of a concept, that is where vector search is coming in. Also, vector search gives you options to search not just text, but also unstructured data like audio or video or images. And you extract the meaning that is not in a textual representation right now, but you can search more for the semantic representation of something. However, that semantic representation falls short, for example, if you search for a very specific name, that representation that is normally a dense vector, think about it as an array of floating point values. It's not very good at if you search for a very specific string. Vector search is not necessarily great at that. So, for example, if you know a name and you want to search for a specific name, that is where keyword search is doing a much better job. And your users get really angry when they know that the string exists somewhere in your documents, but they are not able to retrieve it. So in many cases, you want to have this combination of vector search and keyword search. And maybe you want to have these, like you mentioned before, these additional filters. So, for example, if we have a restaurant search, we might include a geo filter where we say, only give me the restaurants within 5 miles or 10 miles, because if they're on the East Coast, it's not really relevant to what we are trying to do here. If you're searching for a restaurant, or give me only the 4-star restaurants. All of these, you want to have more complex retrieval to actually find what is relevant, because the point about RAG is really, retrieval is very broad. It's also very old. But it's really just about finding the right context. How you get there is almost an implementation detail, and vector search is an important piece or an important option you have, but it's not the only way how to get to that additional context, just to make the generation better then. LLMs are only useful for generating the answer, because in the graphic that I've shown you before, we were generating the answer at the end with the LLM. Who sees the LLM in that place? Okay, nobody dares to raise their hand anymore. Where else could LLMs be relevant, if not for generating the output? Yeah? Processing the input, yeah. This is one of the examples I have here. So let's assume we have this problem here. We have a dessert, but we forgot what the dessert is called. And maybe we can describe it to an LLM. And we can say like, oh, it has ladyfingers and it's from Italy and it has cocoa powder. And then the LLM will actually say, you're looking for a tiramisu. And you might not even want the LLM to generate you the output, because maybe you just want to retrieve the recipe for the tiramisu. You don't really need an LLM to rephrase the recipe, because you really just want the recipe to make the tiramisu. But you might have a problem to actually finding what you're looking for, or maybe to make it a bit broader, you might use an LLM to rephrase your question just to either fit your data better, or just to make it more generic, or just have a better question so that you can retrieve better context to give a better answer afterwards. The other place where LLMs can come in really handy is data is normally very messy. There is this joke in data science that you spend 80% of your time cleaning up data. And that is actually a place where LLMs can give you a hand, that they can help you to clean up your data and structure it better and make it more approachable, maybe give you synonyms automatically, maybe remove certain errors, maybe do something like named entity extraction, like this text is about this person, or this is the overall context, or give you more summaries and you also search the summaries. All of these can very easily be done by LLMs, but it's not just at the end when you output something, but the LLM comes in to both ingest the data and collect it, maybe rephrase your query just to make it better, and then maybe the LLM is also used for generating the output. Right now, we seem very focused on this, like we have a very large document that we just want to have a summary, or we want to have the output rephrased, and this is a good goal, but that is not necessarily the thing that we will always want. Because, for example, if you have a search in a store, you normally just look for the thing that you're looking for. You don't really need an LLM to reformulate the result. You just want to find something sometimes. In other cases, when you have like a 50-page PDF and you want to get the gist of the PDF, or you want to have like an explanation of like a certain section, LLMs totally make sense for the output as well. But it's not always that the generation makes sense at the output or is needed there. Another point that we see quite often is that large context windows make RAG obsolete. Who believes that? Okay, nobody dares to raise their hand anymore. If nobody raises their hand, why?
What's the definition of large?
Well, larger than what we could have in the input tokens like 6 or 12 months ago.
Yeah, I mean, so I think that's the thing where the context window can be changing and the RAG will automatically be able to handle more, right? So.
Yes, but I think some models like have an input like at least 10, if not more, pages of context, which might be enough. So this will be an ongoing question. Or initially, the input context windows were so small that everybody was always like, of course, we have more data than this context window can have. As the context windows keep expanding, maybe there are use cases where you don't need it, but in most cases, you will have just way more private data or data that you want to add as context than what is reasonable to give to your LLM. The other downside is more input tokens normally take more time and cost more, so you want to limit them. The other thing is that sometimes, and that depends on which benchmarks you believe, the LLM gets more confused if you provide too much context or things that are not relevant, and then it will actually give you worse answers rather than if you just provided relevant context, it has a more focused answer, rather than giving you a very broad answer because it got confused by all the input. This is a pretty active area of research, but NVIDIA has recently published an interesting paper in defense of RAG in the era of long context language models, which is interesting because you would think NVIDIA says GPUs, so they would always want more input tokens so they can process more. But they came to the conclusion that, and you can see it in the orange and the blue charts, that in their benchmarks, and they've done quite a few benchmarks in this paper, was that the long context window gave you often worse answers than if you had RAG, though they did use various tweaks around RAG. Or this is one area that is under very heavy research, I would say, right now. So this paper, for example, has these two concepts of like, first, provide enough context. So they retrieve a lot more pieces of content rather than just one, because what oftentimes happens is people just look for the top one document or maybe top one chunk and just provide that as context, and that might not be enough. The other thing that intuitively we're often doing is like, we have a large document and it's for vector search, to keep that reasonable and the relevance high, you might chunk it to break it into these different chunks. And you might intuitively sort by chunk relevance. What they're doing is they're keeping the chunks within one document in order as they appear in the document. So you can see the blue on the left-hand side is like the darkest blue goes to the lighter blue. So the relevance, let's say, is 0.9 for the first two chunks, then 0.8 and then 0.7. But it kind of like mixes up the order, and that can confuse the context as well. So what they're suggesting is that at least for one document, you keep the order-preserving RAG, that you keep the order of the chunks, even if then here the least relevant of, let's say, you retrieve 4 is the first one, but it might still give you better context to keep them in order. Other tricks around chunking might be that you figure out like the worst thing oftentimes what in context you can do is if you mix content together that does not belong together, so that figuring out the separators in a document is very important. For example, if you have a header, that is normally a good point to break, because after, like, the part before a header is normally very different and doesn't belong to it. So this is definitely something where you should have a break, and you shouldn't just say like, oh, I always take like 100 tokens and mix them together across whatever boundary there might be. That is one thing. Another pattern that I think Cohere described last week was that they always added a summary of the entire document to each chunk. And they said that's helping the relevance of the chunk, because it doesn't only find the parts that are in the chunk, but in kind of like in the context where it's coming from. And that gives you much more relevant chunks. Another approach that is interesting is called hide, which the general idea is, if you have a chunk, it's, let's say, a paragraph of text, so it's some amount of text. When you have your search query, it's often much less text. And the idea is vector search. The relevance around vector search is very much built around the similarity between what you're searching for and what you're finding. So what this hide approach is doing, it's taking your query, it's generating a representative document of that, and then looks for similar documents, because it says like, you basically have like, let's say, paragraphs of text, and you're just looking for similar paragraphs. So what you need to do is you need to generate a relevant or representative paragraph, and then you look for similar paragraphs rather than just like 10 tokens or so to search for. So there are a lot of different tricks and ways how to tweak context or to make search more relevant. But the main point here is that search and retrieval is a big field. There are many ways you can do it, but even larger context windows don't make it obsolete to find the relevant pieces, because only with the right information, the LLM can actually generate context in the right way for you. I think we have some more time, and we can actually let's do some stuff live. I always feel bad if I just talk. So let me make this maybe my keyboard shortcuts changed. I always need to use this. Maybe to coming back to my first point about like vector search is potentially not enough. Since we're a search company, I always like to talk a bit about search. And my main example is always Star Wars based. There is this scene in the Star Wars movie when they're sitting in this vehicle and he's making that gesture and then he's saying a phrase. Does anybody know what the phrase is? At the very beginning of the movie. It's a famous phrase, "These are not the droids you're looking for." That's always my go-to way of explaining how search works. And I'll start with keyword search because it's the older one. So what we do here is we'll build this analysis pipeline. This is kind of the equivalent of what you would have in a model to give you an embedding representation of your text. What we do here is we'll throw out HTML, for example, because nobody's going to search for HTML tags. We'll break it up into words. We'll lowercase everything because nobody cares for upper and lowercase when you actually search on Google, for example. Remove so-called stop words, so little words that appear in almost all texts and add very little meaning. And then we stem. Stemming basically reduces a word to the word root, so you don't care about singular, plural, or anything. You throw out the HTML, you break out the tokens, you lowercase, you remove the stop words, you stem. I create this, I put everything into an index I call Star Wars. And now I show you what full text search would do. And this is kind of like what happens behind the scenes. I'm taking this like, these are not the droids you're looking for. And when I run this, what you actually get out is droid you look. This is what full text search could do behind the scenes, the way I have set it up here. So for example, if you would afterwards search for droid, it basically generates a list of all the tokens that you've ever extracted, points back to the document, and then you could easily find this document that talks about droids. And it has a start and an end offset. It knows where the hit is if you want to do highlighting. It knows the position in the document if you would look for a phrase. I know droid U is a very weird phrase, but because one is basically position n and the other one is n plus 1, you know that these were next to each other. And this is what you can do in full text search. So you can just store these then you can search for, so I have, these are not the droids you're looking for. And then I also store like who said it and no, I am your father as a phrase as well. And then I search for droid. Will I find the droids here with my full text search? Yes or no? Yes? Why? Yeah, so we've lowercased it. So the upper and lowercase shouldn't make a difference anymore. We have stemmed it, and the stemming stems down to the word root of droid. So searching for droid and the search term runs through the same pipeline will find my droids. The problem is, though, this vocabulary mismatch. If I say, I don't know, Android or machine, I wouldn't find anything. Or for example, no, I am your father. So if I search for father, you will find something. But if I say, for example, dad, it wouldn't find anything because it's really just about this lexical search. So this is the limitation that you have with lexical search. Vector search, on the other hand, and I'm running this against AWS Bedrock with Titan, and I ran these before because I wanted to take out my tokens before sharing my screen. So it could do completion, and it doesn't know anything about it. This is kind of like the end-to-end example at the end, that if you then inject like who said these are not the droids you're looking for, it could answer the query. But to keep it short, I'm setting up a semantic Star Wars index where I keep what I've done before, and I've just like add that Titan embedding. I take the documents from my previous index and throw them in here. And let's just retrieve that. Just to show you what a dense embedding looks like is like we have, these are not the droids you're looking for. And that vector representation of this with this Titan model looks like this. So you have an array of floating values. This is the representation in a dense vector. And then, for example, if I start searching for robot now, and this is still the query. Here we are still searching for the old keyword-based field. But if I search for my Titan dense vector representation, then it will actually find these are not the droids you're looking for. It will also find the other document. That is the other funny artifact of vector representation, is that everything has some distance to everything else. Because the dense vector representation, and we have a cosine similarity, even if it's totally unrelated, you will still have some distance even to the most unrelated document. There is no correlation at all. But it gives you what is closest, and robot is closest to that. These are not the droids you're looking for, because the model understands that droid and robot are in the same space, or like closely related. It will give you this as the best matching document here. And we have avoided this vocabulary mismatch. But for example, if we would have OB1, for example, a keyword-based search would do a much better job of finding OB1 because we have that exact match than a dense vector representation. And you can also, for example, then search for dad, and this will do a good job or a good enough job to find I am your father as the closest match in my documents here. And you could, for example, also combine those where you combine keyword-based search and vector search just to get the most relevant documents. So all of that combined, these are the options that you have with search, and they give you much better results than just vector search alone. But the retrieval part is really about like finding the most relevant context, and only with that context can you then give the right answers. You totally quote. So LLMs are, by the way, a great tool to make search better. So either you could do automatic keyword generation. it might be a bit domain specific. Sometimes your users are the best source for those. So if you have existing queries, what your users are searching for, those could be a good feeder into that. And then you could say like, or tell an LLM, give me 5 permutations for each one of those. And then you widen the net. So you can totally do that. We also have a proprietary model that is a sparse vector representation that kind of does that automatically for you. It basically gives you a keyword expansion, but with the weight, how well it is matching. So we have done that as a model as well. So dense vector representation gives you a lot, but it's not the only approach. There's also sparse vector representation, or SPLADE is the generic technology if you're looking for that. You can do that. Another area where, for example, LLMs are great is to generate test data, to actually verify what you're doing with your queries. So it's really not, keyword search can totally be complemented by LLMs. And also coming back to one of my other points, it's not just the RAG generating the output, but LLMs potentially have many use cases in the wider search spectrum. And ideally, they solve the boring problems for us, so we can actually spend more time on fun stuff or solve the actual problems. Useful is a pretty broad term. It can be reformulating your query. For example, coming back to your other example of like the synonym expansion, you could have the LLM reformulate the query and say like, oh, give me 3 different variations of this query and then run all of them and see what comes back. Or maybe you can tell the LLM approximately what data you have and you want to restructure the query. So it could be you formulate better queries to retrieve more relevant data. It could be in generating the output, which is the classic RAG. It could also be in generating test data to actually validate what you're doing. So there are various ways to use LLMs just to work around search. You can do a lot of manual work, so you could define all your synonyms manually, but that's probably tedious, and people have done that in the past and spent a lot of time, but maybe you can automate a lot of that and just be faster to solve the job. So LLMs totally have their space in search and software development as a whole, but I'm just focusing on search right now. One area where I think LLMs are the easiest starting point for RAG is to avoid the malicious users and have the benevolent users who want to cooperate with them. So for example, our support team and our sales team are using that very heavily because we have large internal knowledge bases of how to solve technical issues, how to write or how to answer a sales email. And so that's the classic RAG example. We ingest all of that data and then use an LLM to generate an output. And then we have a user to actually validates that, tunes it if necessary, and then uses it. Where RAG is, I think, sometimes a bit trickier is like when you do the prompt injections or talk the LLM into doing something it shouldn't do. There's this well-known example of, I think, a Canadian airline where people talk the LLM into saying you can cancel your flight for free. And they went to court and the airline lost and had to cancel the flight for free because it was their system saying that. So if you have malicious users or users that try to attack your system, LLMs can be tricky, and like putting all the guardrails in place can be tricky. But if you have users who want to use the system and just try to make the best out of it, it's just like us coding or generating SQL queries or finding more relevant content. It's a great use case. If you have a hostile environment, it's interesting, or people are learned to be a bit more cautious. I think there was this other case with like, you get a free car, or you could talk the LLM to get a free car. So there are all kinds of things that went wrong over time, and we are learning how to not fall into those.